This is the part 2 video of back bonding. Here I will be discussing some questions related to back bonding. First question is, write the order of Lewis acid character in descending order for the following compound: BF3, BCl3, BBr3 and Bi3. Okay, so here we know electronegativity and acidic character is directly proportional. Okay, both are directly proportional. So according to us, the answer should be BF3 will be more acidic than BCl3, than BBr3 and Bi3. This is the descending order of acidic character according to us, as expected. Okay, because electronegativity order is FCl, Br and I. Okay, F is greater than Cl and Cl's electronegativity of chlorine is greater than bromine, and electronegativity of bromine is greater than that of iodine. But this order is not true. This order is not true because here in BF3 back bonding will take place. Okay, so here 2p back bonding will take place because the electrons of 2p orbital of fluorine will be transferred to the 2p orbital, empty 2p orbital of bromine. Okay, and the electron deficiency of bromine will decrease. Okay, bromine will not be electron deficient any longer. Okay, as 2p overlapping is better than 2p overlapping, therefore back bonding order will be BF3 greater than BCl3 greater than BBr3 greater than Bi3. Okay, this is the back bonding order, not the acidic order. Okay, this is the back bonding order. And why this is the order? Because in BCl3 here 2p overlapping will be there, and it is less effective than 2p orbital. Okay, overlapping is better in 2p orbital than 2p orbital. Okay, in the above cases back bonding decreases electron deficiency of boron that I have told earlier. Lewis acidic character decreases. That's why, what is the definition of Lewis acid? In Lewis acids the electron deficiency should be there. Electron deficiency should be there. But due to back bonding the electron deficiency is decreasing. Electron is transferred and the electron deficiency of boron decreases. Therefore its Lewis acidic character also decreases. Okay, so the Lewis acidic character order is Bi3 greater than BBr3 greater than BCl3 greater than BF3. Okay, next question. Why bond length of BF3 is less than BF4 minus? In BF3 back bonding takes place. Okay, in the example section in the last video we have read that BF3 back bonding takes place. Okay, in BF3 back bonding takes place, but in BF4 minus there is no back bonding. Okay, in BF3 attains double bond character. See here, I will be showing the previous examples that I have shown. Here I have shown in the previous video, that BF3 undergoes back bonding and therefore double bond is coming. Okay, double bond is coming. Therefore as BF3 attains double bond character, bond strength of BF3 increases and bond length decreases. We know the bond strength of double bond is greater than single bond, and bond strength of double bond is and bond length of double bond is smaller than single bond. Okay, in BF3 minus, in BF4 minus, there is single bond because no back bonding is taking place. Therefore, single bond is there. If back bonding would have taken place, then there in BF4 also double bond would have come, but this is not happening. BF4 is not undergoing back bonding, and therefore there is single bond and its bond length is greater than BF3. Okay, in BF3 double bond is coming due to back bonding, therefore bond strength increases but bond length decreases. Okay, so this was the answer of this question. Then next question. Question number 3. Why bond angle of PF3 is greater than PH3? PF3 undergoes back bonding. Okay, in the example section, in the previous video I have shown that in PF3 back bonding is taking place, and here phosphorus is having 3d0. Okay, empty d orbital. Phosphorus is having empty d orbital, and fluorine will donate its electron from 2p orbital to the empty 3d orbital of phosphorus. Okay, F donates the electron of 2p orbital in the empty 3d orbital of phosphorus. Okay, so here PF3 undergoes back bonding, therefore electron density increases on phosphorus. Back bonding always increases the electron density. Okay, in case of Lewis acidic character also we have seen that as back bonding increases electron density, therefore Lewis acidic character was decreasing in that question. Here, as electron density increases on phosphorus of PF3 than phosphorus of PH3, in PH3 back bonding will not take place because H, hydrogen, has no lone pair, so it will not be able to donate electrons. Okay, so in PH3 back bonding will not take place, therefore electron density will remain same, but in PF3 electron density increases. We know back bond angle of bond angle is directly proportional to electron density on central atom. Okay, therefore bond angle of PF3 is greater than PH3 because electron density is increasing in case of PF3, therefore bond angle is also increasing for PF3. So in the above question, it is asked that what is the bond angle order of compounds H2O, Cl2O and F2O. If we find the order based on electronegativity of side atom, the order will be H2O, Cl2O, H2O is greater than Cl2O is greater than F2O. But this is not the correct order because bonding comes into effect, because back bonding comes into effect. Okay, so we know electronegativity of side atom is inversely proportional to bond angle. Okay, therefore the expected order was this, but it was found that this is wrong order. This order is wrong because among the three, back bonding takes place in Cl2O. Among the three, only in Cl2O the back bonding is taking place because Cl has empty d orbital and oxygen has lone pair. Due to back bonding, the bond angle therefore increases. Okay, so here back bonding will take place only in Cl2O, as in the example previous video I have shown the examples. There Cl2O in O the electronic configuration was this one, and the lone pair was, and oxygen had two lone pairs, and in chlorine it had 3d empty 3d orbital. So therefore oxygen donates its lone pair of electrons to the empty d orbital of chlorine. Okay, therefore back bonding is taking place. So as back bonding is taking place, okay, due to back bonding the bond angle will increase. Why? Because due to back bonding, here first the hybridization was sp3 tetrahedral, and it is converting to sp2 because double bond comes into effect, and here tetrahedral, the shape was tetrahedral and it is turning to trigonal planar. The bond angle we know, sp3 bond angle is less than sp2. sp3 109 degree, almost equal to 109 degree, and sp2 is 120 degree. Okay, so the correct bond angle order is Cl2O, H2O and F2O. Cl2O will come first because here back bonding is taking place and double bond comes into effect. So from sp3 it is becoming sp2 and the other two are sp3. Okay, other two are sp3, but here it is becoming sp2, therefore it comes first. Okay, the other two are sp2. This will be according to the electronegativity order. The rest two, whatever is left besides Cl2O, whatever is left in the order, that will be according to the electronegativity rule that I have shown here. The rest will follow this rule, but due to back bonding, here Cl2O comes first. Okay, then why bond length of BOH whole 3 is less than BOH whole 4 minus? See, in BOH whole 3, in the previous example I have shown that in BOH whole 3 back bonding takes place. Okay, oxygen will be donating its lone pair to boron. Okay, boron is having empty p orbital, we all know, and oxygen will be having 2 lone pair in every case. Okay, so this is so because BOH whole 3 back bonding takes place, therefore it attains partial double bond character and therefore bond length of BOH whole 3 decreases, and in BOH whole 4 minus no back bonding is taking place, therefore it will remain in its single bonded form only, therefore its bond length will be greater than BOH whole 4. Its bond length will remain constant, but its bond length decreases due to because partial double bond character comes into effect. That's why bond length of BOH whole 3 is less than BOH whole 4 minus. And here another thing is there, that is back bonding can affect what? So according to the questions that I have done here, the Lewis acidic character question, okay, first question was that Lewis acidic character, so it affects Lewis acidic character, that means it decreases the Lewis acidic character. Okay, we have seen that here Lewis acidic character decreases, so it affects Lewis acidic character. If it decreases Lewis acidic character, then it will increase the Lewis basic character. And bond length question we have done, bond length it decreases because double bond comes into effect. Bond angle it increases. Okay, hybridization it changed here in the question. Here in this question, hybridization sp3 is changed to sp2, and then shape tetrahedral to trigonal planar, and then stability because it is a type of resonance, so back bonding, wherever there will be back bonding, it will be more stable, the compound will be more stable. And at last, adduct formation, it is given in NCERT. See here, diboron undergoes cleavage reactions with Lewis bases to give boron adducts, BH3L. Okay, see here, B2H6 plus NMe3, BH3.NMe3. Here N will be donating its lone pair to boron, and here B2H6 plus CO, BH3.CO. Here CO, C is going to donate lone pair to boron. Okay, here also back bonding is taking place. Here N is the donor and boron is the acceptor. Okay, boron is having empty orbital and nitrogen is having lone pair, and here boron is having empty p orbital and carbon is having lone pair. Okay, so this was all the questions. Hope you understand all the questions and If you like the video, please like, share and subscribe to this channel. Thank you.